This is the part 4 of mathematical physics. In this video, we learn about special function. First is power series. Using this special function, we can solve differential equation. First method is power series method. If y is equal to here, this is the journal equation. If we can write this equation in a summation form like that. If we do differentiate this equation one time, we get this. Now again differentiate this term. We get this term. Using this method, we solve the differential equation. Let's take an example. Using this three equation, but in this question only y dash is available, so we use this first and second equation for solving this equation. Now put this value in the given question. Equal to 0. In this method, we need to make x raised to power same, so we put in this summation n is equal to n plus 1, and in this n is equal to n. Now this become this. Now taking common x raised to power n, since x raised to power n does not equal to 0, so n plus 1 into a n plus 1 minus a n equal to 0. Now a n plus 1 is equal to a n divided by n plus 1. For getting the solution, we need the value of a naught, a1, a2 up to an. So put n is equal to 0, we get a1 is equal to a0 this term. Similarly, n is equal to 1, a2 is equal to a1 divided by 2, and here you can see here a1 is equal to a0, so we can write here this. Similarly, for n equal to 3, we can write here a3 is equal to a3 divided by 4. Here this is the value of a2. We can write here, sorry for this misunderstanding, here this is n plus 1, so if we put n is equal to 1, we get this. And similarly, for n is equal to 2, we get here a2 by 3, and a2 is equal to a0 by 2, so we can write here a0 divided by 2 into 3. Similarly, for n equal to 3, a4 is equal to a3 divided by 5, which is equal to, here a3 is equal to a0 by 2 into 3, so we can write here and similarly for n is equal to n minus 1, we can write here this is a0 by factorial 3. Similarly, for we can write here an is equal to a0 by factorial n. As you can see from these values, a2 is equal to a0 by 2, so we can write here a0 by 2 factorial. Now put this value in y put this value in y, so we can write here a0 plus a0 by factorial 2 into x plus a0 by factorial 3 x square plus a0 x की power 3 divided by factorial 4 up to a0 x raised to power n divided by factorial n. Or in summation form we can write here, taking a0 common, and we can write this. Now this is equal to exponential e raised to power x. This is a solution of this equation. Now ordinary points. This is second order differential equation where p and q are polynomial of x if x equal to a is an ordinary point if the value of p P and Q does not equal to infinity, if P and Q equal to infinity, so it is not ordinary point. Now, singular point about x equal to a. Let this is a general equation of differential second order differential equation. If P and Q are not analytic, means at x equal to a, P or P equal to infinity, or P equal to Q equal to infinity, then it is not ordinary point but a singular point. There are two types of singular points. First is regular singular point. And second is irregular singular point. In regular singular point, if x minus a into p and x minus a whole square into q are not infinite at x equal to a, then it's said to be regular singular point. In case of irregular singular point, x minus a into p and x minus a whole square into q are infinite at x equal to a. Now, extended power series method. There are two theorems in extended power series method. Theorem 1, if f and g are in the differential equation and analytic at x equal to a, then every solution of the above differential equation is analytic at x equal to a, and can be represented by power series in power of xa with radius of convergence. There are several second order differential equation often found in many applications having coefficient not analytic at x equal to 0, but like this differential equation the coefficient r of form is given below. If at x is equal to 0, if we put, then it's become non-analytic. So now Theorem 2. If y dash the plus fx divided by x y dash plus gx divided by x square into y is equal to 0, this type of equation phenalytic at x is equal to 0 has at least one solution in the form of this. Where m is any number. Let's do their important case. First case is when roots m1, m2 are distinct and not differ by an integer, that is, if we do m1 minus m2 does not equal to 0 or positive integer. For this case, we use y is equal to c1, y is equal to a1 y m1 plus a2 y m2. Case second, when roots m1 m2 are equal, we use this solution. This is second case, when root m1 m2 are distinct and differ by an integer. For m1 is less than m2, we use this condition a naught is equal to b naught m minus m1. So the solution become y is equal to a1 yr1 plus a2 del y over del m m1. If case 4, roots are distinct and differ by an integer and making some coefficient intermediate then the solution become y is equal to a1 y m1 plus a2 y m2. Let's do some question in this four case. Let y is equal to a k x raised to power m plus k y dash is equal to this is a Rodriguez formula as we used here in extended power series method. This is formula is known as Rodriguez formula. So here we use this. Now y double dash is equal to summation a k m plus k into m plus k minus 1 into x raised to power m plus k minus 2. Now put this value in the given condition. We get 3x summation a k m plus k into m plus k minus 1 x raised to power m plus k minus 2 plus 2 into y dash x raised to power m plus k minus 1 plus y equal to 0. Or we can write this equation as 3 summation a k m plus k into m plus k minus 1 into x raised to power m plus k minus 1 plus 2 into summation a k m plus k into x raised to power m plus k minus 1 plus summation a k x raised to power m plus k. Now these are same, so we can take common here and this become and ak also common term here. Plus summation a k x raised to power m plus k equal to 0. Now put in summation 1 k equal to 0 because in this method when we formed this equation we need to put k equal to 0 in lower power of x. So we put k is equal to 0 for getting x raised to power m minus 1. So we get this plus twice m and equal to 0. We take only this equation. Now this type of equation is called initial equation. We can write here on solving this we get m is equal to 0 and 1 by 3. These are the roots of this equation. So these roots are real and distinct and does not differ by an integer. So this is a case 1. So we use here y is equal to a1y r1 m1 plus a2y m2. In this equation we put k is equal to 0 for getting coefficient of x raised to power m minus 1. And similarly for next step we used k equal to 1 for getting x raised to power m coefficient. In first summation and k equal to 0 in second summation. As you see here, if we put k is equal to 1, we get put now putting k is equal to 1 and in summation first and k is equal to 0 in summation second, we get this. Is equal to 0. Now a1 is equal to, first of all solve this equation. Here we get 3m square plus 5m plus 2 plus a naught equal to 0. Now we can write here like that. Now a1 is equal to minus 1 divided by 3m plus 2 into m plus 1 and here a naught. Now for coefficient of x raised to power m plus k, put k is equal to k plus 1 in first summation and k is equal to k in second summation. We get plus ak x raised to power m plus k equal to 0. Now we can write here ak plus 1 into 3 m plus k plus 1 into m plus k plus twice m plus k plus 1 plus ak equal to 0. Now these are common. plus ak equal to 0. So we get general equation of this. Now this is the general equation. So we can find here for k equal to 0, a1 is equal to minus a naught by m plus 1 into 3m plus 2. Similarly for k equal to 1, we get a2 is equal to minus a1 divided by m plus 2 into 3m plus 5, or we here this is a a1 value, so we can put here, this will come this. Similarly, if we put k is equal to 2, we get a3 is equal to minus a2 by m plus 3 into 3m plus 8, and this is a a2 value, so we can write here minus a naught divided by m plus 1 into m plus 2 into m plus 3, 3m plus 2, 3m plus 5, into 3m plus 5 into 5m plus 8. This is value of a3. Now we get m is equal to 0 and 1 by 3. Now for m equal to 0, a1 is equal to minus a naught by 1 plus 1 into 2. So a1 is equal to minus a naught by 2, and similarly for a2, m equal to 0, so a2 is equal to a naught by 20, and similarly for a3, we can write here this. So y1 m1 is equal to, taking, now write this, this is a value of a1. So first of all we write a naught minus a naught by 2 plus a naught by 20 x square plus minus a naught by 480 x cube up to so on. So taking common a naught, and we can write here this. This is a value of y1 for value of m1 equal to 0. Now for m equal to 1 by 3, we get the value of a1 is equal to minus 1 by 4 a naught, and similarly a2 is equal to 1 by 56 a naught, and a3 is equal to 1 by 1680 a naught. Now y2 for m equal to 1 by 3 is equal to this value 1 minus 1 by 4 x plus 1 by 56 x square minus this value. Now we can write this equation here. We can write this equation as a naught into 1 divided by 1 by 20 x square plus a naught 1 minus 1 by 4 x plus 1 by 56 x square up to so on. Sorry for this mistake. These are a and b, some constant. Let's do another question. Similarly, we do here y is equal to summation a k x raised to power m plus k equal to 0 to infinity. Y dash is equal to summation k equal to 0 up to infinity ax in ak into m plus k raised to x raised to power m plus k minus 1. And similarly for y double dash, we can write here m plus k into m plus k minus 1 x raised to power m plus k minus 2. Similarly, we put this value in a given equation. Now solving this equation, we get this equation on solving. Now we need to find initial equation, so we need to use lowest power summation. This is lowest power of x for x raised to power m minus 1. Put k equal to 0 only in summation 2. So we can write here, this is initial equation. Now here m equal to 0 0 0. Now this follow the second case, when the roots of initial equation are equal. These are equal roots, so we use here second case. Now we need to put x equal k equal to 1 for the coefficient of x raised to power m in second summation and k equal to 0 in first summation. Because this is a higher power, now summation become now solving this equation, as a naught minus a1 equal to 0, taking common both, so we can say a naught minus a1 equal to 0. So a1 equal to a naught as m equal to 0 for x raised to power m plus k coefficient. Put k is equal to k plus 1 in second summation and k equal to k in first summation for getting general equation finding a's value. Now on solving this, we get here ak is equal to ak plus 1 equal to ak. Now y is equal to x raised to power m. If you find the value of for k is equal to 0, a1 is equal to a naught and k is equal to 1, a2 is equal to a1 and a naught. So we can say a3 is also a naught. So we can write here y is equal to a naught plus a1x plus a2x square up to so on. This is the initial equation which we use. Y is equal to summation an x raised to power m plus k. So here in this equation we get all values are equal to a naught, so we can take a naught common and we can write y is equal to this up to so on. For m equal to 0, this equation become this. Sorry, for m equal to 0 we need to find del y over del m. At m equal to 0 we get a naught x raised to power m ln x plus x square up to so on. For value of m equal to 0 we can write here you can see only x raised to power m is variable, so these whole term is constant. That's why is equal to ln x raised to power m ln x. Now we can write y is equal to del y over del m equal to 0 plus y1. This is y1. For value of y1, sorry, this is value y1 is equal to a naught into 1 plus x square up to so on. So we can write here this ay1 plus by2 is equal to a into y1 is equal to 1 plus x square up to so on plus b into log x plus 1 plus x square plus x cube up to so on. Now let's do another question. Similarly, we used here y dash and y dash, and putting the value of y dash and y double dash in the given equation, we get summation a k m plus k into m plus k minus 1 into x raised to power m plus k plus summation a k into m plus k x raised to power m plus k plus summation a k x raised to power m plus k plus 2 minus 4 times into summation a k x raised to power m plus k equal to 0. On solving this equation, we get summation a k m plus k plus 2 into m plus k minus 2 x raised to power m plus k minus summation a k x raised to power m plus k plus 2 equal to 0. Now similarly we need to find lower power of x. Here this is a lower value or lower power of x, so we put k equal to 0 in the summation first. We get this. Now m equal to 2 and minus 2 and 2 comes. This is a case second, when m1 and m2 are distinct and differ by an integer, then y is equal to a y m1 plus b del y over del m at m2. So this is m1 and this is m2. Now we need to find the general equation for finding values of a1, a2, a3 up to so on. So put k equal to 1 in first summation and k equal to k in second summation. We get this value. Sorry, we need to put here k equal to minus 1. So we get here this value. Now using this equation, here you can see ak never be equal to minus ak, so we can't put k equal to minus 1 in the second summation for getting x raised to power m plus 1. So now we put here k equal to k plus 2. This type of condition occur when a1 is equal to 0. So put k equal to k plus 2 in first summation and k is equal to k in second. We get this equation. Now this equal to this. On putting value of k equal to 0 and k equal to 1 and k equal to 2 and up to so on, we get a2 is equal to 4 a naught divided by m plus 4 into m, and a3 is equal to 4 times a1, and similarly a5 equal to this, a7 equal to 0, because a1 is equal to 0. So a4 is equal to 4a2 divided by m plus 6 m plus 2, and we can write value of a2 like that. For m equal to 2, we can write y1 is equal to y is equal to a naught x raised to power m 1 plus 4x square. This x square come because a1 is 0 and a3 a5 up to so on. So we can write here only these even terms. So we can write here this. So for m is equal to 2, we can write y1 is equal to a naught x square plus 1 4x square divided by 2 into 6 plus 16x x raised to power 4 divided by 2 into 4 into 6 into 8 plus up to so on. Now for m equal to minus 2, if we put m equal to minus 2, here you can see here the coefficient become infinite of this, because m plus 2 is here. If we put m is equal to minus 2, the whole terms become infinite. So we can use here for this is the third type, so we can use here a naught is equal to b naught m minus m1, this equation. So we can use here m plus 2 because there is a minus 2 here. So y become b naught x raised to power m, and this m2 go inside and multiply, we get this term. Now taking their differentiation, we get this value, and now this is the first part. Now this is second part of differentiation. So this will come this, and plus 16x raised to power 4 divided by m into m plus 4 into m plus 6 into minus 1 by m minus 1 by m plus 4 minus 1 by m plus 6 up to so on. At m equal to minus 2, we can write b naught x raised to power minus 2 ln x plus b naught x raised to power minus 2 minus 1 by x square plus x raised to power 4 up to so on. And we can write y is equal to a y1 plus b y2. We put the value of this, and this y2 is del y over del m at m is equal to minus 2, and this is m equal to plus 2. Now let's do another question. If this is a given equation, similarly we use here y dash and y double dash value and put in this equation on solving. We get summation ak m plus k minus 1 into m plus k plus 4m plus k into o plus 2 plus summation ak x raised to power m plus k plus 2 equal to 0. Similarly here we put x raised to power m plus k. Similarly we put k equal to 0 in lowest power of x. So we can get a naught here. A naught does not equal to 0. We can find the factor m is equal to minus 1 and minus 2. These are the root of the equation, so we need to find general equation to find the value of a1 a2 a3. So we put k equal to 1 in first summation and k equal to 0 in second summation. So we get the value this, and a1 on solving this we get this. Now m1 and m, these m are not equal to 0, so a1 is equal to 0. Now For journal equation, we put k equal to k plus 2. Put k is equal to k plus 2 in first summation and k equal to k in second summation. We get now on solving we get ak plus 2 is equal to minus 1 divided by m square plus 2k plus 7 into m plus k square plus 7k plus 12 ak. For different value of k we get a2 is equal to minus a naught divided by m square plus 7m plus 12. On solving we get a naught is divided by this, and similarly for a3 we get this value, and similarly for a4 we get this value. For m equal to minus 1 we get a2 is equal to minus 1 by 6 and a3 is equal to 1 by 12 a1 and a4 is equal to 1 by 20 a naught. So we can write here y is equal to a naught x raised to power minus 1 for m equal to minus 1. So this is y1 plus a1 1 minus x square divided by 12 plus x raised to power 4 divided by 360 up to so on. For m equal to minus 2 a2 is equal to minus 1 by 2 a naught and a3 is equal to minus 1 by 6 a1 and a4 is equal to 1 by 24 a naught and a5 is equal to 1 by 120 a1. So we can write here y2 is equal to this. If we take common minus x square in this and from this we can write this, and taking also a naught common plus x minus x cube divided by 6 as you can see this is cos x formula and this is a sin x expansion formula. So we can write here this. So we can write general equation like this. This is y2 and this is y1. So we can write here plus, and this is y2 this is the final answer of this question. This question is based on case 4 because you can see roots differ by an integer. Thank you.